Hello, my dear students. Welcome to online virtual classes. Today, we are going to start new subtopic, that is application of derivative, and its subtopic is increasing and decreasing of a function. There are two methods. One is definition method, which is applicable only for the simple function like a linear functions. If the function is complicated other than the simple function, then we'll use the first derivative test to check whether the given function is increasing or decreasing. Okay, I'll going to explain by giving the example. Okay, let me start by first definition method, which is applicable only for the simple function. Now there is a procedure to there is a considerations or method to solve the questions by definitions method. Okay, let me explain by solving the questions. Suppose there is a function, we need to always consider the 2 points. Okay, we need to always consider the 2 point x1 and x2, which is belong to the given set. Okay, either it is a real number set or other set. Okay, now in this case we are considering that these 2 points x1 and x2 belongs to real number, and always assume that x2 is bigger than, according to the method, according to the definition method. Okay, this is the definition method. Definition method, and it is applicable only for the simple function. Simple functions. Okay, if the function is complicated other than the simple, always we are going to use the first derivative test. And for to apply this method, always consider there are 2 point belongs to the given set. In this case, I am considering the given set is real number, and this consideration x2 is always bigger than x1. x2 is always bigger than x1, and from these relations or considerations, we have to check whether the given function is increasing or decreasing. If the again, if fx2 is bigger than fx1, that means fx1 x2 is bigger than x1, similarly fx2 is bigger than fx1, then the function is said to be, then the function is said to be increasing. Okay, increasing in given set. Okay, so it's set or interval. Okay, if fx2 is less than fx1, because we consider, according to the assumption, x2 is bigger than x1, after solving the questions, after solving the function, if it is come like this. Okay, if the symbol change to small side, okay, if the symbol change to this, because we consider x2 is bigger actually, but after solving the function, or after going through the function, if it is come like this, if x2 is less than fx2 is less than fx1, then the function is said to be, then the given function is said to be decreasing. Okay, function is said to be decreasing in given set or interval. Okay, now I'll explain by giving one example, and remember, this is not much important, it is applicable only for the simple function. Okay, let me consider one function example. I'll explain by giving one example. Example, suppose consider fx equals to 5x minus 7. Okay, this is the simple function, and this is called linear function, and for simple function only we are going to use this method. Okay, now according to the procedure, let me consider on R. Okay, question asks to check whether the function is increasing or decreasing on the real number. I am not writing the questions here, I am just writing the function. And just remember, question asks to check whether the function is increasing or decreasing on R. Let me, okay, for to apply this method, we are going to consider 2 points. Let x1 and x2 belongs to given set. The set is real number here, such that x2 is always bigger than x1. This is the assumption. Okay, now by using these relations, we need to convert this given function into these relations. Okay, now convert this relation into this function. Or now what is there? The coefficient of x is 5. There is one coefficient is there. That's why we are going to multiply this relation, this inequation by 5, because there 5 is there. If there is 3, we'll multiply by 3. If there is other number, we'll multiply by the same number. Okay, now multiply by 5 both side. Okay, now 5 multiply x2 is 5x2 is bigger than 5x1. When this symbol get reversed, if you multiply or divide by negative numbers. Okay, let me explain here. Suppose 5 and 2 is there. Which one is bigger? Can you tell me which one is bigger? Yeah, obviously 5 is bigger. Okay, obviously 5 is bigger. If you multiply and divide, if you multiply or divide by negative number, suppose we are multiplying or dividing by -1. Suppose we are multiplying and dividing by -1, multiplying or dividing by -1, then now it is -5 and -2. Now check which one is the bigger here. Obviously -2 is bigger. That's why remember when this symbol get reversed, if the numbers, if this relation is multiplying or dividing by negative numbers. And one more things, another one is also there, reciprocal. Okay, reciprocal of 5 is 1/5 and reciprocal of 2 is 1/2. Now obviously 1/2 is bigger. That means there are two conditions is there. If you multiply or divide by negative, this symbol get reversed, or if you reciprocal the relation, again it gets reversed. Okay, remember these 2 points. Otherwise symbol remains same, it does not change. Now we make 5x. Now 5x is there already, 5x2, 5x1 is already there. Now one more term is there. What is there? -7. Now we are going to add -7 both side. We are going to add -7 both side. Adding -7 both side. Adding -7 both side. Now this function is changed to 5x2 -7 is bigger than 5x1 -7. Remember, when this symbol get reversed, multiplying, dividing by negative number and reciprocal in the relations. Okay, now look at here. There is a fx, that's why it is 5x -7. Suppose look at here. Suppose this is fx equals to 3x plus 4. Then if we replace this x by any others later, suppose I am replacing this by a, then it is 3a plus 4. If we are replacing here, we need to replace there also. Okay, if we are replacing here, we need to replace there also. Suppose it is replaced by b, then this is 3v plus 4. Suppose if it is replacing by x1, and this is 3x1 plus 4. Okay, similarly, suppose if you replace this by x2, then this is 3x2 plus 4. Same concept we are using here to convert into function. Now this is there is a x, that's why it is fx. There is a x, that's why it is fx. Now there is a x2 is there, then function is changed to fx2. Now this is this is fx2 and is bigger than fx1. Okay, fx2 is bigger than fx1. Okay, now according to the these points, okay, if fx2 is bigger than fx1, then function is said to be increasing on given interval. Therefore, now look at it, this first condition and this is are same. That's why we're going to give the conclusion. Therefore, f is increasing on R. On R means on given set. Okay, f is increasing on R. That means this is an increasing function. Okay. Okay, let me give you the same kind, whether this function is decreasing. One more example. Okay, let me show you one more example. Suppose another function is like this. Suppose fx equals to minus 4x plus 9. Okay, this is a function. Then question asks to check on R. Okay, question asks, this is another example. Okay, example 2. Always consider like previous one, let x1 and x2 belongs to R such that x2 is always bigger than x1. This is the procedures, okay, to check the function whether it is increasing or decreasing. Now according to here, the x is multiplying by minus 4. Check there, minus. In previous case there is no minus. Okay, in the previous case there is a plus 5 is there. That's why in this case the coefficient of x is minus 4. That's why we are going to multiply this by minus 4. We are going to multiply this by minus 4. Okay, multiply by minus 4 both sides. Now this is minus 4. Okay, this is minus 4x2. I already said to you, if the relation, if this inequation relation is multiplied by negative or divided by negative number, the symbol get reversed. Okay, now we are going to reverse the symbol here. Now we are going to reverse the symbol here. Now this symbol get reversed. Now this is less than. Initially it is more, x2 is more than x1 is there. After multiplying by negative numbers, the symbol get reversed. Now it is less than minus 4x2. Okay, now one more term is there, that is plus 9. Now we are going to add plus 9 both sides. Adding plus 9 both sides. Now this is minus 4x2 plus 9 less than minus 4. This is x1. Okay, sorry, this is x1. Remember, this is x1. 4x1 plus 9. Now like previous one, now this is function fx2 and this is function fx1. Now this is function fx2 is less than this is function fx1. Now symbol get reversed. This x2 is less than fx1. That's why if the final relations come like this, according to the definition method, if x2 is less than fx1, then function is said to be decreasing. Okay, therefore we will give the conclusion. Therefore f is, you can write strictly decreasing also or decreasing. F is decreasing on R. Now this is decreasing function. Okay, this way you can solve the simple questions by definition method. After going through, try to solve few questions from your textbook. If you have any doubt or if you need some more clarity, please comment me or WhatsApp below. Till there, we'll meet in the next video. Till there, take care, stay at home, stay safe. Thank you for watching.